Genetic mapping using fairies. This is Amy and Amelia. There are a few key alleles that make Amy and Amelia look the way they do. To demonstrate genetic mapping, I will be using 3 linked loci found in their species: skin color, wing type, and hair color. Purple skin is dominant to green skin, white hair is dominant to blue hair, and butterfly wings is dominant to curly wings. We will start by looking at Amy and Amelia's grandparents, or the P1 generation pictured here. We know that the grandfather is homozygous for all dominant alleles found in the linked traits, and their grandmother is homozygous for all recessive alleles. The grandmother gave birth to a daughter, Anna. She is part of the F1 generation. Anna is heterozygous but shows all the dominant phenotypes. Anna will later give birth to Amy and Amelia with her husband, who is homozygous recessive. This is the grandparents' genetic map. There are 19 centimorgans between skin color and hair color loci, and 10 centimorgans between hair color and wing shape loci. The coefficient of coincidence is 0.8. Using this map, we can predict the probability of the 8 gamete types that could be created by someone who is heterozygous for these traits, like Anna is. Using the reverse mapping technique shown in the table here, we are able to predict the frequency that one of these crossover/recombination events will occur during prophase 1 of meiosis. This slide shows what a no crossover and a double crossover would look like. I have highlighted where the double crossover event occurred on the right at the hair color loci. This shows a single crossover at the skin color loci and a single crossover at the wing type loci. They are also highlighted in these pictures. Amy's specific phenotype resulted from a double crossover event. To determine the probability of this, you multiply R1, 0.19, R2, 0.1, and the coefficient of coincidence, 0.8, which equals 0.0152. This number is the frequency of a double crossover event occurring as a whole, which means the results could either be offspring that has purple skin, blue hair, and butterfly wings, or it could be offspring with green skin, white hair, and curly wings. To find the frequency of just offspring with Amy's phenotype / genotype, you would divide 0.0152 by 2, which is 0.0076. This is a probability of 0.76%, less than 1%. Amelia's phenotype, green skin, white hair, and butterfly wings, resulted from a single crossover event occurring at the skin color loci on the chromosomes. To determine the frequency that her specific gametes would occur, take S1, 0.19, and subtract it from the frequency of a double crossover event occurring, 0.0152, which equals 0.1748. Just like in the last example with Amy, this number represents a single crossover event occurring at the first loci with both possible genotypes. To get the frequency of Amelia's genotype / phenotype, you would take half the frequency, which is 0.0874, with a probability of 8.74%.